Okay, so we're gonna do a practice problem with energy. I always start by writing my equations for energy over here. Potential energy equals mass times gravity times height. Kinetic energy equals 1/2 mass times velocity squared. Now there are other energies like a spring or possibly work, because work and energy are closely related, but I typically don't write those unless they're in the question. So let's read the question. A 10-gram rock, there's your first problem. The mass of the rock is 10 grams, but we cannot use grams, we have to use kilograms. So we're gonna change grams into kilograms. So grams is on top, we put grams on the bottom so they cancel out, and we go to kilograms. In 1 kilogram, there are 1,000 grams. So if we do the math, we're gonna have 0.010 kilograms. Okay, so 0.010 kilogram rock is placed in a slingshot with a spring constant, so that's spring, so I'm gonna come down here and write my equation for potential energy of a spring, which is 1/2 kx squared. So let's read the question again. A 10 kilogram rock is placed in a slingshot with a spring constant of 250. So the spring constant is K, so that's 250 Newton meters. The rock is stretched back, so that's the distance, that's the x, 0.800 meters. After the slingshot is fired, what is the maximum velocity of the rock? So velocity equals question mark. So we have a little picture here kind of showing us what's going on. So we have a slingshot being pulled back, the rock's here, and we're gonna shoot it forward like this, okay? So when the rock is pulled back, all of the energy is potential spring energy. And when it's released and the rock is now launched, all of the energy becomes kinetic. So that's our relationship. So the potential energy of the spring has to equal the kinetic energy of the rock when it flies. So we just write this equation for the potential energy of spring, this equation for kinetic. We end up with 1/2 k x squared equals 1/2 mv squared. The halves cancel out mathematically. Plug the numbers in. Our k becomes 250 times x squared, which is 0.800, and that squared equals the mass of the bullet, remember, is 0.010, and then 010, okay. And then the velocity squared, and that's what we're trying to find, is that velocity right there. So we do a little math. We get 0.8, it's squared, so we times it by 0.8 equals, times by 250 equals, we get 160 over here, equal to 0.010 v squared. So divide by 0.010, divide by both sides by 0.010, and our velocity equals, actually it's velocity squared still, 160 divided by 0.010 gives me 16,000. I'm gonna finish the problem right here. So now I take the square root of both sides, because we just want v, not v squared. So the square root of 16,000 gives me 126.5. So I'm gonna say 127 meters per second. And the answers to these problems are multiple choice. So you wanna look for the answer that's closest to 127, because there are some rounding that we have to do in here, and we may or may not have done the rounding exactly how they did it on the answer key. But that's how you do it. The main idea is to know that the spring potential energy equals the kinetic energy of the rock. And by that we can find the velocity down here.